Hello, good morning. My name is Jagendra Singh. Title of my paper is Eagle Eye Enhancing Online Exam Proctoring through AI-powered eye gaze detection system. So, in the abstract of this paper, with the significant rise in the online examination, the demand for proctor has grown exponentially, leading to resource constraints. Unlike offline exams, we have a few invigilators overseeing large groups of students. Online exams require individual monitoring to uphold the code of conduct. However, the prevalence of unfair practices among examinees in online exam remains notable higher than in offline setting, resulting in an extensive and inefficient process. To address this challenge, we present Eagle Eye, a coherent and efficient system that employs eye gaze detection and machine learning and artificial intelligence. During the exam setup, examinee undergo a calibration test to establish a designed border box area for eye movement testing. Data gathering from this detection enable classification of examinee behavior as fraudulent or fair based on their gaze within or outside the box. In the introduction part, in the current era, where technology play a crucial part in the successful operations of various sectors like employment, education, and the retail sectors, it became essential to develop solutions that facilitate smoother process and enhance effectiveness. With this vision in the mind, our team introduced Eagle Eye. Eagle Eye, as its name indicates, act as an additional eye and a monitor tool that may be utilized in a variety of economical areas. However, for the scope of their papers, we concentrate on its applications in the education sector. We believe that successful completion of this endeavor can potentially lead to its implementation in diverse fields such as crime, marketing, automobiles, and many others. This innovation aims to make these challenges times more manageable and elevate the efficiency of both workers and educations. The underlying goal of this paper was straightforward, impactful to improve the mechanism of online testing and education. We determined that the lack of an proctoring techniques was the main issue. This deficiency created a significant gap, allowing students to engage in unfair practices without encountering an obstacles. Unlike the conventional offline examination method, when one invigilator is in charge of a complete class of pupils, the online methods give each student its own proctor, which requires significant cost outlined from organizations. Even with a proctor present, it might be difficult to spot unfair tactics such as utilizing notepad phones to look up answers or other quiet techniques because the video does not alter or make noise, which make effective monitoring difficult. So, subpar outcomes of the current process, but a heavy burden on organizations conducting these examinations. Not only does it lead to unfair and inequalities results, but it also requires significant allocations of human resources and capital for employing proctors. These elements lead to a considerable gap between the online examination system and the current proctoring procedures. To address these challenges and introduce a more robust approach to examinations, we propose the implementation of Eagle-Eye. The solutions aim to provide a more straight and reliable methods ensuring fairness and effectiveness in the examination process. So, in the related work of this paper, since 1935, technology has improved significantly, especially with the recent development of computer vision technologies, which has promoted the creation of more sophisticated and safe tracking of eye and gaze detection techniques. So these concern methods frequently rely on photo taken with digital cameras that show face or eye. In many cases, the gadget's built-in webcam may act as the camera, as demonstrated by this study and WebGazer at Brown University eye tracking library. So for a long time, researchers and scientists in the field have been doing considerable study in the area of gaze detection and tracking of eye. So between eye movement, connecting connections between eye movement and the potential of electrodes on the outmost layer of the skin in 1849, which lead to the investigation of these issues. The use of placed electrodes on the temple and coupled to a effectively measures potential variation associated with eye movement, was then proposed in the research paper published in 1935. So these historical milestones highlight the longest standing interest and invigilation in this domain. So in the groundbreaking study, Jang and Bulling introduced an initial convocation neural network-based method for gaze detections. Surprisingly, despite its higher economical cost, this straightforward gaze estimate method outperformed many traditional appearance-based methods, so the effectiveness of this CNN approach oversaw financial considerations. So, in conclusion, despite the long history of gaze detection and research, there is still much room for improvement, especially given the increase in popularity, the use of deep learning, computer vision, and artificial intelligence in recent years. The ongoing achievements in this area suggested there is still a lot of grounds to cover and work to be done in this area of gaze detection. So the methodology of this paper, so the development of eye gaze detection studies shown in figure 1 in the research paper. There are two major sections to it. The focus of the first section is on training models, while the second selection include real-time testing. The central part of the process called model training involves creating and deployment the model for use in real-time applications. On the other hand, real-time testing involves the user interaction and utilization of fully optimized deployed models. To build the model, the first equipment is to dataset to work with. It is crucial to have a well-featured dataset that will be processed using various machine learning and pre-processing techniques to guarantee a valid and trustworthy dataset. We plan to create one from scratch. From this purpose, we will seek volunteers who will participate in a mock examinations aiming to recreate an environment similar to an actual examinations in order to gather the information required for the model training and optimization. We will take video of the volunteer. So, for instance, if the video has 30 fps rate, frame per second rate, we only need one frame per second. We employ CV2 and timer to extract the required frame. In the phase of feature extraction, we want to find the individual eyeballs and then figure out whether they are with regards to face and screen. For the model to be initialized and to process to be calibrated, these coordinates are essential. Recognizing the identifying the user gaze depend upon precise eyeball locations and detections. So to achieve this, the localization process can be divided into three distinct parts. First, localizing the face in the image. Second, localizing the eye positions and gathering information about the surroundings. Third, detecting the pupil within the eye and calculating its center. So this approach minimizes computational space and speed up to process by bypassing the need of classifiers to process and classifying the entire image. It became less error prone and more sophisticated. The eye gaze detection system overall effectiveness and accuracy are improved by this optimized method. So in our study, our cascade classifier are used to identify the face and eye in an image. The HAR based the classifier model is an image analyzing as well as machine learning approach for identifying object in image or video. So it is was the first presented by Missile John and whole video to 2000 to it employ a variety of unfair and, and favorable images to categorize the collections of images according to their significance or value according to the categorization. So the result, if I talk about this paper, so tracking the eyeball motions and locations coordinate is the most important part of our gaze detection task, which we have successfully done. The observation eye of the who like one of the guy who is one of the group members, we first turned the obtained eye image to a pixels in grayscale to increase accuracy. We then converted it into an inverted Gaussian blurred image alongside with threshold value being determined instantly from the live video. The station below helps to clarify the statement by giving an illustration of this procedure. By assuming that the origin is the bottom left corner of the screen, we were able to determine the base distance d2 from the eye coordinates. Employ the distance calculation formula from the origin to determine the actual distance d1. We manually determine the real coordinate of the eye. The absolute variation between scale of the base and actual distance was then used to calculate the error. We determine the precision A proportion for our paper was three distinct frames that were employed in a method shown in Figure 4 of the research paper. The accuracy rate was attained 98%, 97%, and 98.75%. So, yeah, for concluding this research, we aim to develop a extensive eye gaze recognition system capable of precising, determining, examining tasks during exam by focusing the phase detection, eyeball detection, and eyeball tracking techniques. The system's utility extends to Proctor, providing them with valuable insights into candidates' behavior, and to examine organization, adding and ensuring the integrity and fairness of the assessment process. In this paper, we meticulously crafted the eye gaze detection model by leveraging cutting technologies and machine learning algorithms. So the model enables us to classify and examining gaze behavior into either fraudulent or fair. The classification process results in straightforward 0 and 1, simply the interpretation of the outcomes. The significance of the research lies potential impact on academics and professional examining, enhancing the overall integrity of the evaluation process. So this is the conclusion of this paper. So thank you very much.